All right, welcome to today's lesson. We are going to be factoring expressions today, factoring expressions. But let's start with just a little bit of a warm-up. We're going to triple. Triple means times 3. The product of 3xy times 4gz. So, like the last lesson, I'm just going to start by expanding it all out. So writing it as a product with multiplication symbols in. So factoring, so writing it as a series of factors is expanding it all out. So I'm going to take my numbers and multiply. So 3 times 4 is 12. And then I'm going to write my variables in alphabetical order. So G, X, Y, Z. So I dealt with my numbers first and then my variables. And now I'm going to triple it. So 3 times 12 is 36. G, X, Y, Z. Notice that I am just multiplying the numbers. I'm not doing 3 times 12 and 3 times G and 3 times X and 3 times Y. We're not doing the distributive property because, I'm going to erase this whole thing, aren't I? Because the distributive property only works with addition and subtraction, but we'll get to that in the next lesson. All right, so this page kind of seems common sense. It is common sense, but we're leading to something. So how many 5s are in here? So there are 2 5s. How many 3s? There are 2 3s. So what does it represent in words? We could write 2 times 5, and there are different ways to do this, plus 2 times 3. So when we write the expression, we would do the 2 times 5 plus 2 times 3. And again, that seems pretty basic, but it's leading to something. So now look at this problem and see if you can answer the questions. Again, how many 5s, how many 3s, what does it represent in words, and how could we write it using symbols? All right, this one is different than the last because instead of the 5s being together, so there's 2 5s plus 2 3s, or the sum of 2 5s and 2 3s. Now we have the 5 and the 3 next to each other. So we have this sum and this sum, so it's double that sum. So yes, there are 2 5s and 2 3s, but it's in a different order. So this represents a different expression. We could say 2 times the sum of 5 and 3. Or we could say double the sum of 5 and 3, but it's the sum that is being doubled. So how we could represent this is 2 times the sum of 5 and 3. So is it equivalent? Yes, it's equivalent. It means the same thing. There are still 2 5s and 2 3s. We just wrote it in a different way. We wrote it factored. All right, this is the same exact concept except different variables and numbers, and I would like you to try this on your own first because then after we do this, we're going to be going away from the model. Okay, so let's see if we match. So what 2a means is 2 times a, and we can see that there are 2 a's and there are 2 b's. So this is 2a plus 2b. So it's this plus this. So that's how I wrote it. Here, it's same concept except it's arranged differently. Now there are 2 a's still and there are 2 b's, but it's this sum doubled. So the expression would be the sum a plus b times 2. We're doubling it. So I want you to look carefully. Yes, first of all, they're equivalent because there's still 2 a's and 2 b's, but look to see how it is different. It's written differently. Here's our 2, and instead of multiplying first, we are adding first. We're taking the 2 and we're adding the a and the b and then multiplying them both by 2. They're equivalent, they're written in different forms. All right, so what you are going to be doing in this lesson for your assignment and on the summative assessment is using the greatest common factor. So what factor they have in common, the greatest one, just like when you were working with fractions, and use the distributive property. I think of it as going backwards from the distributive property to write an equivalent expression. So first, here's our problem, 3f plus 3g. What is it asking us to do? First, we have to look at the greatest common factor, and we're writing it as a factored problem. So we're going to pull out, or we're going to expand it to where we're pulling out those things that they have in common. So how would problem 1 look if we expanded each term? It would look like this. 3 times f plus 3 times g. So what do they have in common? What is their greatest common factor? They have 3 in common. So we're going to pull that 3 out and think of it, instead of 3 times f and 3 times g, we're going to put the f and the g together, and then there is 3 of them. So there's still 3 f's, and there's still 3 g's, but we took that greatest common factor out. So if we wrote it a different way, it would be like this. That's a plus symbol. So there's still 3 f's, there's still 3 g's, so we wrote it like that. All right, so I want you to try the next one and then come back. All right, so I expanded it out. I wrote my 6x as I broke down 6 to 2 times 3 and then times the x, and I broke down my 9, 3 times 3 times y, so I can see that greatest common factor. What they have in common is this 3 right here. So if you take that 3 out, and it's still part of the problem, but if you take it out, you can see that there would be 2x plus 3y 3 times. So I took the 3 out, and I was left with a 2x right here and a 3y. So again, what that would look like is instead of having x plus x plus x plus x plus x, etc., plus 9 plus y plus y plus y, we are taking our 3 x's and our 3 y's, and we're taking this 3 times. So there's still going to be, I'm sorry, I said 3x, it's 2x. So there's still going to be there's still going to be 6 x's and 9 y's. We just factored out that 3. So you're looking for the greatest common factor. And if I went forward, and we'll talk more about this tomorrow, if we did the multiplication, 3 times 2x is my 6x, and 3 times 3y is my 9y, so that works. All right, so next problem, 3. Is there a common factor in 3? Well, I'm going to start by expanding it and then trying to rewrite it. So again, I want you to pause and do these and then come back. Okay, let's see how you did. So is there a common factor? Well, when I first looked at this, I'm like, no, 3 and 11 don't have anything in common. So I expanded it out. 3 times c and 11 times c. So yes, actually they do. They have a c in common. So we're going to factor out, we're going to divide out that c. So 3c divided by c is 3. We're left with a 3. And 11c divided by c is 11. So I can rewrite it. So I'm multiplying c by the sum of 3 and 11. All right, this one. I did not break down the 24 as far as it could go because I saw this 8 here, and I knew that 8 went into 24. So I broke it down to 8 times 3 times b plus 8. And then since I'm trying to factor it out, and I needed to write it as a product, so I needed 2 factors. So I did 8 times 1. So now I can see that they have the greatest common factor of 8. So I'm pulling that 8 out. I'm dividing that 8 out. So 24b divided by 8 would leave me 3b. 8 divided by 8 would leave me 1. So by doing that division or factoring, breaking it down, I'm left with 8 times 3b plus 1. So why is there 1 in the parentheses? Well, it's like a placeholder. If I didn't have it, I'd have nothing to account for this 8. So if I did the multiplication, 8 times 3b is 24b, and 8 times 1 is 8. So if we wanted to do a visual where each of these are b's, and we have our 1, we would have this 8 times. So that would be 8b plus 8b plus 8b plus 8, which is our 24b plus 8. Okay, so here it just says to apply the distributive property to write equivalent expressions. It's exactly what we were doing. We're writing it in factored form. So factored form is just an expression that is a product of 2 or more expressions. So you're looking for that common factor. So they have 7 in common, so I'm going to divide that 7 out. 7x divided by 7, I'm left with x. 7y divided by 7, I'm left with y. So you're taking out that common factor. Okay, so please try to do these and then come back. All right, let's see how you're doing so far. Here, the 15 and the 20, I needed to see, like here, they were single numbers, 7 and 7. That was easy to see. This one might not be so easy, so I wrote it in expanded form, 3 times 5 times g and 4 times 5 times h. So I see that they have this 5 in common. So if we took that out, if we divided it out or we factored it out from both expressions, we would be left with 3g and 4h. Here I did the same thing. I wrote it expanded. So 30 can be broken down into 3 and 10, and 39, 3 and 13. So they have this 3 in common. So I took out the 3, but if I take out the 3 here, I'm left with 10a. If I take out the 3 here, 13b. So I took out that 3. All right, what about the last one? Here, 11f and 15f. What I see in common is that f. So I'm going to take that out. And what am I left with? 11 plus 15. All right. The very last thing that I'm going to ask of you is to evaluate to see if they turn up with the same thing. So evaluate, remember, means filling in the numbers and doing order of operations to check to see if it works. So I'm going to do 6 times 3 plus 21 times 4. And then I'm going to do the same thing with this one. So could you please pause and do the arithmetic for both of these problems and then come back. All right. First I want to just point out that I know I'm not showing order of operations correctly. This should be down here and this should be below, but I was running out of space. So when I plugged it into this where that 3 was factored out and I plugged the numbers in, I substituted the 3 and the 4 in, we did come out with the same number. So these two expressions are equivalent. All right, I'm going to let you try this one on your own. see what you come up with. Let me know if it is equivalent or not, and then start your assignment. We out.